Hi everyone, welcome back to Data Cadence. My name is Rahul and I work as a senior applied research scientist. And in today's video, we are diving deep into an important yet often overlooked topic in machine learning, that is calibration. Now, calibration is one such topic which I see even a lot of senior people missing out on, or they are not even aware of this, but it's really important from a realistic perspective. So, this is the agenda for today. We will talk about what is calibration in machine learning, why is it important, what are some of the methods to calibrate a model and how do they work, and when and how calibration should be performed, and what are the potential consequences of not calibrating a model properly. So, without further ado, let's begin. So let's start with what do we even mean by calibration, right? So calibration refers to the process of adjusting the probability estimates of a model to better reflect the true likelihood of a particular outcome. So for example, if you say that your model predicts a probability of zero point 0.7 for an event, we want to be confident that there's actually a 70% chance of that event occurring in reality. And that's what we mean. So particularly calibration is very crucial in scenarios where the predicted probabilities are used for decision making. So for example, in medical diagnostics or in risk assessment. So basically wherever the stakes are high and underconfident or overconfidence models can basically lead to costly mistakes, that's where you would need to use some sort of calibration on top of your model output. Wherever the cost of making mistakes is high, that's where you need calibration. And now you might ask, why is it important? So the main reason is reliability. A well calibrated model provides probabilities that you can trust. That means if your model predicts something with a probability of 80%, you would expect it to happen 80% of the time in the real world. And on the other hand, a poorly calibrated model might predict a 80% chance, but the event only happens 50% of the time. And this mismatch can lead to misguided decisions, especially in high stakes environment like healthcare or finance, where probability estimates are used to trigger actions or make critical decisions. Now let's talk about how to perform calibration. So there are several methods to perform calibration, but two of the most commonly used ones are. So the first one is Platt scaling. Now Platt scaling was originally developed for SVMs, but it can be applied to any classifier that provides a decision function or uncalibrated probability scores. And let's talk about briefly how it works. So Platt scaling uses a logistic regression model to transform the uncalibrated scores, also known as logits, of a particular classifier into the calibrated probabilities. And if f of x represents the uncalibrated score for any given input x, then the calibrated probability, that is probability that y is equals to 1 given x, is given as 1 over 1 plus exponential of a times fx plus b. Yes, this is very similar to what you have learned in logistic regression, because essentially you are fitting a logistic regression here, and a and b are the parameters of the logistic regression model that are learned from the data. Now you might ask when to use Platt scaling. And one more thing, the parameters a and b are optimized by minimizing the negative log likelihood on a validation set, exactly what you do in logistic regression. And this effectively ensures that the predicted probabilities are as close as possible to the actual outcomes in the validation set. And when to use Platt scaling? So Platt scaling is simple and quick. It's a relatively simple and quick method to apply, and it requires only logistic regression to transform the scores. So therefore it's pretty simple and quick. So that's one of the advantages. And the second one is when the data is not too complex. So Platt scaling works well when the data is not overly complex and the uncalibrated scores are somewhat linearly separable, since we are using a logistic regression here. Now let's talk about some of the limitations of Platt scaling. So the first one is the parametric assumption. So Platt scaling assumes that the relationship between the uncalibrated scores and the true probabilities can be modeled with a sigmoid function, which may not be always the case, especially if the data has more complex patterns. And the second one is binary classification only. So Platt scaling is primarily designed for binary classifications, although for multi-class classification use cases, you can use extension like one versus all and so on to extend it to multi-class classification. Let's talk about the second method, that is isotonic regression. So it's a non-parametric calibration method that does not assume any particular form, like we assume the logistic function in the Platt scaling for mapping between the uncalibrated scores and the two probabilities. And it is more flexible than Platt scaling and can adapt to more complex data distributions. It is particularly useful when the reliability of the probabilities is more crucial than the interpretability of the calibration model itself or the calibration method itself. like we use logistic regression in Platt scaling, which makes it much more interpretable. But that comes with a cost of accuracy, right? So there is always a trade-off between the accuracy and the interpretability. So in short, isotonic regression will give you more accurate probability estimate, realistic probability estimates, but it would come at the cost of interpretability of the method that you are choosing. And it requires more data to avoid overfitting, and of course it can be computationally more expensive when compared to Platt scaling. Now I'm not talking about how does isotonic regression works, because that is a bit more involved and out of the scope of this particular video. I can definitely cover that in one of the other videos if people are interested, but let's stay out of that for now. So when to calibrate a particular model? That's a very important question. So you should calibrate a model after the model has been trained and validated, but before it is deployed. This is really important because it's pretty crucial to understand when you should apply calibration and when you should not. And it is important to recalibrate your models periodically, especially if the data distribution changes over time. So for example, in a customer churn model, if market conditions or customer behavior shift significantly, your model might need recalibration to maintain that same level of accuracy. Now let's talk about some of the potential consequences of not calibrating your particular models. So if you don't calibrate your model properly, you run the risk of your model being overconfident or underconfident in its predictions. And this can lead to first thing, which is overconfidence. So your model might predict high probabilities for events that are less likely, leading to risky decisions. And the model might predict, the second one is underconfidence. The model might predict low probabilities for likely events, causing missed opportunities or overly cautious actions. The third one is misallocation of resources. So in a resource intensive applications, miscalibrated models can lead to inefficient allocation, such as misdirecting medical resources or financial investments. And the fourth one is reduced trust. So stakeholders and decision makers may lose trust in the model's prediction if the probabilities consistently fail to align with the actual outcomes. So always remember, a well calibrated model is not just accurate but also reliable, providing probabilities that you can trust to make informed decisions. So in conclusion, calibration is a critical step in the machine learning pipeline, particularly for applications where probability estimates play a key role in decision making. Always ensure that your model's probabilities are aligned with the real world by using appropriate calibration techniques we discussed, like Platt scaling or isotonic regression. So the next time you build a model, don't skip on calibration. Your model's reliability depends on it. And with this, we come to an end of this particular video. And also, this is also a very important interview question. So like I mentioned, even a lot of senior people struggle with these concepts like calibration, or they are not even aware of this. But if you were aware of it, hopefully it was a good refresher, and if not, hopefully you learned something new. So if you found this video helpful, make sure to like, share and subscribe to Data Cadence for more data science insights and guide around interview prep. And I will see you in the next video then. Until then, stay safe and happy learning.